All right, let's look at the homework 8, problem number 25. And we are looking for the absolute minimum value of the given function on interval from 0 to positive infinity. All right, so let's do that. All right, so let's look for the critical number. So we need to find the derivative. So f prime of x is equal to, all right, so you have in a quotient format, so I'm going to use a quotient rule here. All right, square the bottom, so x cubed square would be x to the 6th power. All right, derivative of the first top guy is e to the x still, and multiply by the bottom guy, x cubed, minus top guy is e to the x, and the derivative of the bottom is going to be 3x squared. All right. So we can pull out the common factor. So there's going to be, let's see, x squared would be in common, and also e to the x is in common. All right. So if you do that, you can see e to the x is pulled out, and x squared. So I'm going to just circle the power so that there's another x there, and here x squared is pulled out. So what's left is just going to be x minus 3. Right, we divide by x to the 6th, and we can do a little bit of cancellation. X squared here, so there's an x to the 6th, so we can reduce that to 4. All right, so that would be the derivative. So I'm going to just clean it up. I'm going to write it as a x minus 3 e to the x over x to the 4th power. All right. Right, I'm going to set this guy equal to 0 to find the critical number. So it looks like the only critical number would be, all right, so we can make the numerator equal to 0, right? X minus 3 times e to the x equals 0, right? But the e to the x is never 0, so only chance we have is make x minus 3 equal to 0, which means that x equals 3 is the critical number. So we have a critical number, right? So, and also the domain, we're talking about from 0 to infinity. So if you do the number line check here, so here from 0 to infinity, then the critical number is at 3, right? Then I'm gonna check the shape increasing decreasing behavior here, right? I'm going to try something like x equals 1, which is between 0 and 3. And I'm going to try something bigger than 3, so I'm going to try 4 or something like that. All right, then let's look at the sign of this derivative. All right, if you plug in 1, 1 minus 3 is going to be negative. Everything else is positive. So you're going to have a negative sign here. All right, if x equals 4, 4 minus 3 is positive. Everything else is positive. So which means that they have a positive. Right, which is a good sign because if you look at the shape of the original function, and looks like it's going to have a decreasing in the beginning, and after that increasing. After x equals 3, it's increasing. So you're going to have a minimum value there. Right, so let's type it in. Right, so we have to find the minimum value too. So, but we definitely know where it occurs. It occurs at 3. Right, then we have to find the f of 3. So f of 3 would be, right, e cubed over 3 cubed is 27. Right, so that's the answer. Right, let's type in, so minimum value would be, right, let's do the fraction. So you have e cubed over 27. Right, check the answer. Let's see, answer is good. Checked. Let's see, what did I do? Minimum value. Oh, I rounded to 2 decimal places. All right, so that was a problem. So I'm gonna bring out the calculator. All right, so we just need to compute e to e cubed, and then divide it by 27. All right, and hit enter. Right, it's at 0.743, so 0.74. Right, so I'm gonna put 0.74. All right, so let's check the answer. All right, got that. All right, that's it. I hope that this was clear.